Hello, everyone. Welcome to another Wolfram language design review session, part of our language completeness and consistency series. And we have a few topics here today. Replace plus association. Okay, what is this story?
Okay, so this is a somewhat complicated story, so we'll just have to start at the beginning and go through that. Right, so some functions force evaluation when you, in fact, probably most functions which operate on associations force evaluation. So you see we map pound squared and we get a goes to 2.
A goes to 4. We get A goes to 4 out.
Right.
And on the right-hand side of the second thing, because it's a delayed assignment, delayed rule, we don't get evaluation.
Right. Now, because it's sort of forcing evaluation when it does this, it'll behave quite differently from, functions working on sort of general expressions, right? So in the second example,
let me understand this. If I take this, okay, and I map the same thing onto a list here. Actually, I'm gonna map it at level 2 onto a list.
Lists are already very different because it'll apply to the keys as well.
Yeah, I know. So how do I do this?
Maybe just do a list of the values. That would be the analogous thing to an association, right?
Yeah, except that we don't have the delayed rule here.
I guess. I would just put that value in a hold, maybe.
Let's do a map at here. Okay. And then let's do a map at let's see, 1, 2, 2, 2.
Can you just say all, 2? But okay, yeah.
Oh, yeah, I probably can't say all, 2. Actually, let me just do that just for the sake of whatever. Does it work?
Not sure if that was certainly on the roadmap. Yeah, we did do that for map at.
Okay, all right, okay, fine. So this is consistent with that, which seems sensible to me.
Right.
Okay.
But it's actually forcing evaluation, right? The way it normally works is it, inserts the function and then lets evaluation proceed. So if you look at the next pair of inputs, you'll see a difference.
Okay, because the side effects are different. Because in one case, map normally just wraps F. If I say map F onto AB, it just maps the F onto the A and B and then returns the result, and then evaluative takes over, correct?
Correct.
The point is that if it were hold complete of A comma B, then for F, it's the same. But if F was supposed to evaluate, then it's different. And then the key point is that association is hold all complete.
Yeah.
Right. Although I would argue that it is hold all complete, but like it kind of shouldn't be, or like it's kind of a fiction that it is most of the time.
But actually,
it only is because. Go ahead.
Sorry, the association itself is wrapped in hold complete, and yet that hold complete is powerless to stop this evaluation from happening. I think that's the issue.
I see. So it's not that the fact that the association itself is hold complete; it's the fact that it's wrapped in a hold complete.
And yet it still evaluates rules.
I see. Yeah.
I see. So in other words,
it doesn't need to be that way. I mean, the point is you've encountered something that's going to suppress evaluation that's independent of whether it's a rule or a rule delayed. But that information is not passed down to the function that then goes and applies the function to the association. So if that hold, if map encountered hold or hold complete and passed that recursively for itself, and then passed that information to the function that association apply uses, then it could override its own default, which is to check for a rule or a rule delayed, and always use the rule delayed case instead of determining it on the fly. So I think that's just
wait a minute. You said something, Mark. Hold on. You said association apply. So is that an internal function or an external?
Yeah, it's an internal function that when it sees an association, it's going to apply a function to the value.
Okay, so that's the forced evaluator. That's the
yes, exactly. And when that sees that makes a default choice, it says, is the rule a rule delayed, in which
I get
case
it.
I won't
I get
evaluate
it.
it.
It's
or is it
context
a rule?
independent. It just sees the
Yeah.
association. It doesn't do it.
Exactly.
The question of how it got there is invisible to it.
Exactly. So if that information was propagated down and passed into that function, then it could kind of override its own default strategy.
Okay, do we care? I mean, so what are these other examples here? Go ahead.
Right. So, So, for example, replace has never forced evaluation. Sorry, replace all has never forced evaluation, which is
Even inside an association or not?
Correct. So that's the, others respect to hold all complete. So I guess that, that sort of that middle pair of inputs with the X integer and the X, just X blank, right? You see a 2 squared there rather than a 4.
Okay, so hold on a second. Let me just understand. So inside map, somehow this association apply thing, is that being called by the internal code of map? Or where is that getting called?
Yes,
Okay,
when it
so
recurses
replace
down.
doesn't do that. Replace doesn't do the analog of that. Replace,
Right.
So
Right. Sorry, is there a difference between why does the top one, why does it matter whether it says X underscore integer?
Right. So in one case, it's right, it doesn't match the association. So it goes inside and it does the replacement to each element. Whereas when it's just X blank, it squares the integer and then, power is rewriting the whole association.
Okay, I see. So that's doing something totally different. Yeah, it's just doing the association squared.
Right.
Okay. Right. The first one is pretty confusing, though. I mean, that's like an accident of the fact that association is hold complete.
Correct. And so
I'm profoundly confused. The first one, that it burrows to the point where it sees 2, it sees that matches X underscore integer, but because this is hold complete, it does the replacement as it would inside any held expression, but doesn't evaluate anything.
Correct.
Right.
Whereas in this case here, the X blank is matching the whole association, and it's just doing its standard, I'm squaring my values.
Yeah. I mean, the real question here, I mean, the real weirdness is, again, just a consequence of the fact that association is hold all complete. I mean, because of course, if you do a replace all over hold all complete, it's going to behave like that, where you're going to end up with a 2 squared.
Sure.
But if you do that on a list, you're not going to get a 2 squared. It's going to evaluate.
Okay.
So it's sort of very different behavior.
Why is association hold all complete?
Well, I mean, in the sense that's a bit of a fiction, but basically associations as raw expressions are not subject to infinite reevaluation. So,
but they pretend to be.
You mean, I see, the evaluator itself, because it is a raw expression, as a matter of implementation, the evaluator is not recursively called.
Correct.
So any evaluation that has to be done is done by hand, so to speak.
Right.
And that's what the association apply. But so the fact that it has the mark hold all complete, that's not the main point. The point is really that it's a raw expression.
Yeah.
Right.
Whose behavior in the evaluator, I mean, the evaluator right now, its behavior is if you see a raw expression, just ignore it. And anything that goes inside has to be custom done for that type of raw expression. But in principle, the evaluator, just like the evaluator has cases for ordinary expressions with different attributes and so on, the evaluator could have a case for associations that just says, go inside and do your evaluation, couldn't it?
Well, that's a question, I guess, that Mark and Tom should opine on.
I mean, yes, it could. The question is, should it?
Right. Well, my next question is, what is the heinous thing that happens here? Because I'm worried that, for example, Mark's context carrying by map is just another pump trying to keep the ship from sinking. And it's not going to, you just add more pumps. It's not going to work in the end. To say, let's emulate something which is really an evaluator change by something which just involves, particular cases. Now, having said that, the meta theorem is the only evaluator that has no weird behavior is an evaluator that does nothing. So I don't think it's going to be the case. In other words, we've got some weird corner cases here, but that's in compensation for the fact that most of the time it does the right thing. And the question is, should we worry about the corner cases? I think I have a bad feeling the corner cases are unfixable. In other words, we can fix a particular corner, but then there's going to be another corner that shows up and so on. And the question is, when do we stop?
Well,
So,
I don't know. I mean, again, the behavior is pretty well defined for lists, for example. So, I mean, I feel like I don't really see why it would be that fundamentally different with associations, other than just historical implementation choices that were made, a decade ago.
God, it's been that long. Okay. But all right. So if we did like a list, if we thought that associations should operate like lists, does that resolve all semantic questions or not? For example, are the keys evaluated? Are keys evaluated? I don't even know.
Yeah, that is one of the issues sometimes with thinking of associations. It's like, quote unquote, just like any other expression, is that behavior, like things like replace all and expecting it to run on the keys, is kind of unexpected, but it's also kind of what you want.
Right, except that in a lot of functions the keys are ignored, right? So in the initial construction there, right, the keys are evaluated because when you're first constructing an association, it evaluates everything inside according to normal rules. Yeah. But if you map anything or you use any replace function, then it's going to completely ignore the keys.
Or maybe try to have key functions specifically.
Yeah, there are key functions.
Yeah, but maybe try if you say X, if you make an association with X as a key and then define X.
Exactly.
Watch it not
and then reevaluate. Yeah.
Get evaluated. Well, you need to save that in a variable or something. But
yeah, and then you want to get out 13.
Right. But if you do that with a list, then the X would have reevaluated, presumably. So
okay, so this is a case where we see the difference.
Yeah,
right. Only in the keys, though, notably. The values still behave just like a list.
Yeah.
Do they?
Is that true when it's
okay, actually, sorry. In this case, they might not, but I would argue that they in theory should. Like I think keys.
Okay,
the keys
really
are a little
weird.
bit.
Look what just happened there. So that actually didn't evaluate.
No, you have to do. You've got the output. You need to get the input.
No.
What?
It's got a freaking X in it, and I said X equals 9.
Once the association is created, it doesn't evaluate.
No. Don't tell me. Look. If that was a list, okay. If I did the same thing with a list.
Yeah, well, clearly, yes.
Right.
The list isn't whole or complete.
Right, I know that, Tom, but I'm just, we know. We're asking what it does and what it should do. And that, okay, so here, if I say %121, it'll evaluate, right?
Yes.
Okay, so the question is this, how much are we upset that it doesn't evaluate in the association case?
It would be terrible if it evaluated.
Yeah, it would make association useless.
Explain it would be useless. Why. Explain
because
why.
You have a large association that stores a lot of data and information. if the structure of it changes or if it needs to be traversed every single time, if there's a content
Right,
code
okay,
class or
fine.
a symbol
I
or
think you're
anything, it would
explaining-
render
okay.
it useless.
Okay,
It's
Okay,
terribly
so that
inefficient.
is semantic difference here. Why do we think that this corner case about map makes any difference, given that big semantic change? In other words, are we arguing about something that is worth arguing about or not? Or is it just the case associations work differently? They hold their innards because that's an important thing for their efficiency, and that has the consequence that map behaves differently in them.
I
Is
mean,
there
they
anything
do
wrong with
work
that?
differently. The question is, do we want to try and iron out a few of these fringe cases, which could be done in a reasonable way?
Okay.
Or do we just say they are a consequence of the fact that it has different semantics?
I think
And I
that-
also think there's a difference between this didn't evaluate, but when you look up the key, then it's going to evaluate, which means that it was basically just a delayed evaluation until you needed the value, so that's fine. Versus this thing was inside hold complete, but yet map decided to do the evaluation anyway.
Okay,
And the whole point of hold,
that's kind of weird. Okay, that's the but you know, the semantics are going to be weird relative to what we normally have because of this fact. I mean, it is behaving as if, okay, so the one thing which is visibly a bit iffy is the fact that association apply is doing its business even when association normally doesn't have any. In other words, we made the choice.
Right. So let me zoom out for a second. Right. Yes, there is the issue with, you know, map forcing evaluations even inside of hold all complete when there's an association inside of hold all complete, which, you know, bites people every now and then. But, you know, once you know about it, you can deal with it. There was this other issue that replace all never forced evaluation. Replace did sometimes, but not other times. And basically for 13.3, even though this is a bit of a, you know, this is definitely an incompatible change, we've decided to make replace behave like replace all and never force evaluation.
I think that's 13.2.
I think that I'm pretty sure that's 13.3.
You remember better than I would, so
Okay,
I'll go
well,
with that.
anyway, so we're not shipping it yet, is basically what you're saying.
Correct.
Okay. So, I mean, essentially the issue here is the only thing which seems shocking is that, okay, so normally there is evaluation going on in values. And you're saying that even when you put armor in there to prevent evaluation, it still manages to go inside and do the evaluation, which is a little bit shocking.
Yes.
Okay, so the question is, should it detect the presence of armor? What is the armor? The armor is colon greater than, or what? What is the
Or
stuff
hold
that,
complete around the association or something.
oh, a hold
Correct.
complete around the association? Oh, for goodness sake. I mean, oh, I see.
Right. If you said hold complete of an association, then outside of that, you say map at level 2 or something. That's
Yeah.
where you'd see the most
The map
egregious
activates
problem.
inside the hold.
Right. So
Right.
we see
And-
that we see the 5 print and we see that the value is null, as opposed to in the list case where it just, you know, wraps the the 2 print
Yeah.
and as opposed to just wrapping the 2 in print like it did in the list case.
Okay, I get it.
So
So maybe just as a question.
so that's a
is
shocking
there
case. And then we had this inconsistency, and you know, the question is, are we okay with the resolution of just we make all the replace guys be consistent, they don't force evaluation, because perfectly honest, when you're dealing with held expression, you know, manipulating held expressions, it's much more common to use replace type functions than map type functions.
Look, I think it's weird that map sort of explodes on contact inside
Right.
this hold complete thing.
Right. So,
But there's
the question I was
nothing
going to ask
else to
is there a way of getting around it, right? Like, is there some, because presumably if it didn't evaluate, well, right. I mean, there's some cases where like if something doesn't evaluate, you can make it evaluate. But here's a case where it does evaluate. Is there any way of stopping it?
I doubt it, except making it inert, making the thing you're injecting. I mean, basically, what this is you inject this thing and it blows up inside, and you can't stop it, even though the thing is frozen. So that's bad. I admit that that's bad.
Right.
So let's come back to
right. So the only workaround right now is to, you map a symbol F and then you /.f goes to whatever you actually wanted.
Do we have other cases of forced evaluation, even inside hold complete?
The only ones I'm aware of are association. I won't claim that's an exhaustive knowledge, but
okay. Well, Mark, you had this proposal of maintaining the information that you went into a hold complete.
Yeah, so the recursive function that's used by map goes down level by level by level. It would need to see if it ever encountered, you'd have to have a bookkeeping of the heads of things like hold complete, maybe unevaluated. And then it would just pass around a flag, an extra parameter in the recursion that would say I'm inside hold or complete.
All right. I retract my statement about how horrifying that is, but let me ask a question. If you do this inside trees, do we have any tree representatives here?
We have Ian.
Oh, Ian is here. Great. The tree expert. All right. So how does this relate to, how do trees relate to associations in terms of their holdiness?
I would say trees can't have transformation rules attached to them like expressions can. So like once you have a tree, like there's no need to like wrap it in hold or anything like that. And
yeah, but this particular issue, there's a tree map, right?
Mm-hmm.
And allows you to map inside a tree.
It evaluates everything, so it's not like map.
But what happens if you say hold complete of the tree? And then you say tree map into the hold complete of the tree. What does it do?
Well, I think tree map will just complain because it doesn't
work on hold complete.
Right, okay. You'd have to like map the tree map into the actual tree portion.
Okay, so the issue here is, okay, so ordinary map does what on a tree?
Nothing.
What do you mean by nothing? It just treats the tree as
it treats it like a raw expression.
Well, as a raw expression or as a normal expression?
No, I think it's a raw expression. I think it does nothing. It doesn't go inside, which may be a mistake.
Yeah, it probably treats it like an atomic expression.
Mm-hmm.
I thought trees were not raw expressions.
Right, I think they're normal, right? They're normal expressions with maybe some extra stuff.
So this did what the heck did this do?
Well, look at the full form. It probably just well, either it's atomic Q or it just did something horrible to the full form.
It is.
Oh, it's
atomic. Okay.
It's a raw expression, yeah.
Yeah, well, so that's, that of course would be the way that associations could get out of this. Just say, is to, pull the atomic flag, so to speak.
Well, I think they are atomic Q, aren't they? But they still let you map over them and stuff.
Yeah, it's going to be very bad if you can't map over an association.
Well, right, but wouldn't I like to be able to map over a tree as well?
There's in their tree map.
We have tree map.
And why don't we
have
work?
Well, tree map allows various in addition to actual map specifications, right? It allows all sorts of tree specific specifications,
traversal order, etc.
Fair point.
It's really quite different. It applies the function to the data and evaluates that result everywhere.
All right, to conclude this segment, seems to me Mark should investigate the possibility of doing this flagging. I'm a little bit nervous about it, but it seems like that's the least horrifying of the possibilities.
Okay.
I mean,
Okay.
there's a lot of related, there's all the map variants, there's scan, there's, a few
Yeah,
things.
Well, I
the
assume that
problem
they
is to
all use
make-
the same recursive descent mechanism.
I doubt it. I doubt it very much.
Yeah.
Ah, sigh. Well, Mark should do an investigation, figure out what.
Yeah, that sounds good.
All right, on to the next item. Oh my gosh, this is a big item.
Yes, I mean, these are both, and it's sort of not unrelated to the previous item. Right, so if, once we actually have, right, this is an ongoing conversation.
Okay,
And-
but in this world of manipulating held expressions.
Yep.
I mean, the primary objective here is various kinds of metaprogramming, code transformation, and things like this, right? That's what we'd be like to be able to do. And does this work?
That's a working example right there.
But that's all fine. What's wrong with that?
I'm not saying that's just an example.
So Nick is pointing out this map at evaluate, which is an interesting twist on the whole association evaluation thing.
Right. I mean, and this is undoubtedly just doing /semi true.
What?
This is basically map at using immediate evaluate, which doesn't exist yet, but was greenlit.
Right. So remember, we talked about having an immediate evaluate, an immediate binding, and some theoretical person who has time to work on it will implement these.
Which is part of the held expression stack.
Correct. Right.
And what would immediate evaluate do in the context of the association conversation we just had? If you replace something, if you replace that right-hand side by, if you did a map which involved an immediate evaluate, if you said map immediate evaluate blah blah blah,
well,
the
then that first input would give you A goes to 4 and B goes to 9.
If what? If I said here,
Immediate evaluate of that pure function.
Like this.
I think it would want to go around the whole function.
I see. So it's really a
right. It's a tag which says rather than just sticking in the function and then letting the evaluator take over force evaluation at the moment you stick it into the expression.
Right. So this is what apply association apply, whatever it is doing by default. Is
effectively
it immediate evaluate wrapped there by default?
Yep.
Not as heinous as it might be. Okay. Okay. Well, this seems like a good mechanism, which is, I guess, why we designed it before. All right. This seems like a huge topic, this held expressions topic. And it seems like, is there more? I mean, I'd like to make sure we make progress on the supplied thing.
Okay. Well, we can, I think, skip ahead to supplied.
Okay.
Right, which was right. So this was sort of where we left off last time, which was a couple more months ago than I would like, but here we are circling back. You wanted us to prepare a list of functions that could benefit from the contextual variables and supplied. And so
This seems a much shorter list than I would have expected.
It's kind of a list of lists if you look closely.
Yeah, no, I see that.
It looks like there are probably like 40 functions here. Maybe not 40.
Right, so let's take color function as an example. I see, that could have all kinds of stuff.
right. So for example, right now with color function, you need to go to the ref page and look for, for this viz function, what the arguments are, which arguments are supplied in which order, right? And it's going to be different between plot and parametric plot and plot 3D.
Yeah.
And if we had some way of sort of naming these things, then you could, right? So not all values of not all keys would make sense for all functions,
right.
But we could have family of things that all the viz functions could
right.
share.
There are also ambient things like the image size you could pull in here.
Into color function, I'm not sure I see how that would be relevant, but
well, I mean, let's imagine, yeah, well, it is actually sometimes relevant. You want to darken things if they get too small and stuff like this.
I see.
Right. So in other words, right now, there's no situational awareness, so to speak, for color function. It only sees, the function has no way to grab things from the outer, the color function itself has no way to grab things from the outer, function call. But how far did we get? I mean, for example, with map, we had a list of possible variables like index and things like this, right? Level. And so
on the
right?
featurized supply ref page, supplied ref page.
Right, which of course doesn't include all of these functions. This was sort of, we looked at that ref page last time and you're like, we need a bigger list. So we went out and made a bigger list.
Okay. Has any of this stuff been implemented?
No.
So what did we figure out here about, I'm sorry?
Mechanism. Some of it for tree map, but with a different mechanism, not supplied.
Yeah. What did we figure out about supplied with one argument? That you can just do it, right? Without the element names in the beginning.
I thought we had agreed to not do a supplied with one argument because for those situations, you can use contextual variables.
What do you mean contextual variables?
You'll have like a pure function with, I don't remember what our
With
most recent.
like the dollar things.
And it just pulls in the index into your pure function or whatever.
Okay, what happened to the $$ index stuff? And what's the relationship between that and supplied?
We have two lists here. One is things that could use both, and one is things that could only use contextual variables.
Right. And right, the relationship is that the contextual variables are, right, they have sort of inherent meaning, whereas with supplied, right, you give a mapping between the things you want and your pure function, because right, you may have a function f, right, that you want to use with supplied, and you can tell it, first argument is head and second argument is level.
I see. Rather than naming them.
Correct.
And maybe another way of thinking about it is that the supplied is not necessarily lexical, right?
Yeah. The contextual variables, something worries me about them. I mean, so you're imagining that we do things like we instead of map index, we would say map f of hash comma dollar index. You know,
The slightly strange thing is that, you know, right. Why is there a hash and not just dollar element? If you get what I'm saying. Like at some level, there's no reason to even have the function. You could just have, you know, 10 contextual variables, but then it wouldn't be held. So
that was something we discussed. You could literally have an f of dollar index with no ampersand, and it would work because it replaces the variable in the function.
Oh God, you know, there's something horrifying about this. This is exactly how SMP worked, and
right,
led to this ridiculous thing. Having done this, okay, there was then this notion of what I called marks, which were the way of getting around not having, because you have an ambiguity, okay? If you have this and you say f of index ranged, it's very weird that gets lexically substituted, but that, you know, this doesn't get lexically substituted and gets wrapped.
Mm-hmm.
So I think the compelling use for them is like replace things where you have a right-hand side.
Well, right. I mean, replace is how we first started talking about them. But I think it's some of the replace. Like I don't know. I still think that the use cases for functions that take pure functions are a lot more compelling than use cases for functions where you'd have sort of a supplied like thing on the right-hand side of a rule.
Can you do the right-hand side of the rule some other way by having it on the left somehow or something? Or it doesn't know where the rule, I mean, there might be some other mechanism for, you know, I mean, one could imagine something where one just says, you know, rule environment or something. Blah, blah, blah.
Or maybe it's on the left and it's sort of like, what was that thing? I mean, there's a thing we talked about the canonicalizing pattern and stuff like that, where the idea is you could put sort of pattern variables inside this left-hand side thing, and those pattern variables will be bound to all sorts of, you know, all sorts of stuff. So you could imagine having like a I don't know what you'd call it, a localized pattern or something. It's a bad name, but position pattern of, you know, x underscore comma p, and p will be bound to the position in the overall expression where this pattern was found.
What is this? So
no, so x underscore
comma p.
Yeah, and then arrow something rather, and then the idea is that x will be bound to the expression that this thing is matching to, and p can be bound to whatever you want. So it will be bound to, you know, the position where this replacement is being made.
Supplied. I mean, this is very much, it's kind of an inverse of supplied somehow.
Right, but it's forcing you to choose a name for this thing.
Right. So you know, it might be something like pattern supplied, and then one could say something like, this isn't the right syntax, but something like p colon.
It would just be x, not x underbar, surely.
Well, no, because presumably you can tell it, you know, I only match to an integer, right? This is like pattern, where on the one side you have the symbol p, and on the other side you have the pattern that you'd like to match to, in this case, x blank.
Right, so something like this, a pattern supplied.
Well, I'm not sure that colon makes any sense. Right.
But it's naming the index.
Is it vararg, or do you have a list if you want to do more than one?
I don't know about that, but the basic point here is, okay, so then
it's useful to have a generic function like that, though. I mean, especially for just generalized pattern matching. I can't really imagine of many things you'd like to supply. I mean, there's the position, there's maybe the index, if we're making that distinction.
Yeah.
What else? The depth.
The level, the negative level.
I'm not sure.
But these things you can mostly get from the position. So
yeah, fair enough.
You can't get the negative level from the position.
Right.
To be clear.
Well, it makes one wonder about these other. I mean, here there's lots of convenience pieces because you could argue all of these things you could get from, apart from you can't get the negative level from the position. But I mean, which of these?
Well, how would you have something similar? I mean, right? I mean, we talked about this with like map. Like if you want to basically have something like map index, but you want to be able to do it in map, how would you do that with any similar mechanism? Like I think this is a somewhat pattern specific thing because it's all about binding to some variable.
Well, I mean, I assume that it's this, right? That this, whoops.
It'd be position, not index.
Oh, yeah, right. Well, yes, that's the unfortunate thing. I mean, this would be that, comma, f of hash.
Yes.
Just put
that's one.
Just put F.
But how do I get the expression?
Hash 1 is the expression, hash 2 is the position, right?
How
By
does it
default,
know? How
if you
does
just give it-
supplied?
So
decide
here's what we talked about last time. So supplied of a string, comma function, we'll put the main argument in hash 1 and we'll put the string mentioned value, so position here, in hash 2. If you give it a list of strings though, then that list will correspond to the arguments of f, right? So you'd say, quotes, argument, comma, quotes, position, comma, quotes, whatever, and those would correspond to hash 1 through n. Which does mean that supplied of list position is different from supplied of just position. If that makes sense.
Yeah, which is okay, I think.
Yeah.
So
You
it
need
reminds me a
you
little
need
bit
an
of something.
ampersand after the F.
What's that?
You're missing an ampersand.
After the F.
Yeah, it's still a pure function.
Right there where your
Right.
cursor is.
It should either be F or it should be F of #1, #2, ampersand.
Okay.
Right, and I would say the strength of supplied is that you can just put a symbol F there and define it somewhere else.
Right.
Okay. And then the alternative that we'd imagine, which I think is semantically a bit horrifying, is the idea of having, instead of that, having f of this, comma, $, index. God, that's so like SOP.
That's not it. I agree. That's not the supplied is a much cleaner design. This is a little bit like adorning a function to give a different type. So we don't have types for functions, but you could imagine if we had, choosing a function of a different type, picking up different arguments to pass in, picking up a different version of map. Just saying that.
Yeah. I mean, this is some kind of polymorphism, wrapper.
Yes. Yes. I think that's good. It's like function oriented and polymorphic. I think that's clean.
Well, what it's doing is it is supplying. I mean, I have to say this name supplied. We keep on referring to it as supplied, which means this probably isn't a bad name. We spent a long time thinking of other possible names, but I don't think this name is terrible. So let's see. So I mean, the semantics here, I really think this will work. Something like this, whether it's this here, which has a resonance with the supplied concept.
I think the pattern supplied you have there really doesn't make any sense.
Why?
At least the way you've written it.
Well,
But both because of the thing of I'm not sure what you want other than position, but also, I mean, the way you've written it, the P : index means a position that matches quotes index. It really doesn't make any sense.
Like a rule.
I mean, another thing, by the way, that presumably you could write if we supported this thing, although it would make it a little more complicated, is instead of writing P, you could presumably write a pattern, and it would only match things, that pattern would be applied to the position. So it would only match things at a position that matches that pattern, if that makes sense.
But then that P would need to be a P plane, right?
I'm sorry. Yeah, I'm. This isn't quite as silly as I think you're claiming that it is. What I'm
Sure.
claiming is that this p colon index, just like you can say x colon blank, means the matching is for blank, the name is x. This is saying the matching is with the x blank, the name, you're binding another name, it's p,
Well,
and that's bound.
It's like
Yeah, but the-
bind. It's like bind.
Right, but the colon, like pattern, the colon there, I think it's a pattern construct. It's not something, you know, and it means something if it has a string on the right.
Right.
I see what you're saying. I see
Right,
what
P
you're, I
colon
see what you're
index
saying.
is
All
a
right,
pattern.
all right, I agree. That's a reasonable argument.
It could be a key in an association.
Yeah, or an arrow would be better than, yeah.
Right. But this
But honestly,
is
maybe it could be, I mean, is there a reason it shouldn't be P blank actually? I mean, it would make the implementation a bit more complicated.
That would be for position pattern, right?
Yeah, for position pattern, you'd write X blank comma P blank.
I see, which means it matches any position.
Mm-hmm.
Right. And
And the
it
position
binds
is
the
bound
position to
to
P.
P.
Yeah.
That's nice because among other things, you could then expect to have something which we absolutely cannot do right now, which is, you know, slash semi length of P less than whatever it is.
Sure. Yeah.
That's a nice construct.
Well, that
Because that gets us two things.
that you actually sort of can do using like replace in a level specification, but you couldn't do, say, you know, first of P is greater than 2 and less than 7.
Right. Or like, oh, the you know, every other argument of the P has to be a 2 or something like that. Right.
This is nice. This is a good idea. Right, I like this. Okay, so let's see how this would then go along with. I mean, how many of these things here, which are part of supplied, you know, okay, so the point here is there are lots of potential other things. This came up in trees, where there are just lots of other potential environmental variables that you would want to consider.
Yep.
This is a good construct, this position pattern thing. I like that.
I'm not sure. So, sorry, I was just glancing at the rough page, and there was something like position and current position, which I'm not sure I understand what
For which?
is. Right, there's position and current position, and I don't know what.
I haven't thought this out. It may not even make sense, but the idea is the position refers to the position in the original expression. But if you're changing the expression, then you're also changing the positions.
You don't know you've changed it yet, because the thing what map is doing is just filling in structural stuff, and it's then going to evaluate it. It wouldn't. There's no way it can know. That's for the future.
Well, it doesn't map it like at multiple levels. Doesn't it go from the bottom up? Like map all.
I was thinking about this originally for trees, where you might do like a breadth first, and if you're,
I see. Yeah,
you might be shoving the rest of the tree down into deeper levels as you're doing it. But I don't know. I don't know that either.
But supplied. I mean, I think we should implement. You know, we should start trying to implement supplied. I don't think the $$ index thing is a good idea.
Okay.
I mean, what do other people think about that?
Well, you know that I was skeptical of it from the beginning.
Was I its big enthusiast?
Yes.
So we're doing position pattern and supplied.
That's what I'm thinking. But let's think for a second. I mean, you know, the only thing that's bad about supplied is how long and ponderous its syntax is. although
and it still maybe has the pseudo problem that in the actual body of the function, you still call them hash1 and hash2 instead of something like hash position, which might be more readable.
Yeah, which might be much more readable. And I don't think we know how to do that. And I think it would be much better if, in the end, okay, so I mean, this would be magnificent if this could be made to work. Something like that could be made to work.
I mean, I think that was the original thing we talked about, but it was kind of deemed a bit too magical.
Well, I mean, it would clearly be unmagic if there was the following piece of semantics, which I think is probably insane. Okay, if this is insane, probably.
Well, it's multiple levels of magic. It's magic because you have hash and hash position. It's magic because you have hash position, but you haven't told it what keys you want, so it has to be able to lexically look and see the position is the only one you use. And it's magic because ideally you wouldn't want to construct an association for each iteration.
Right. I mean, yeah, right. Okay, so
Also,
the question
double
really
ampersand is taken.
I know double ampersand is taken. That's why I put a space. I mean, the question is there any lexical mechanism I mean, there's nothing wrong with this except for the fact that it's hard to type and to understand when you see it in code, which and it also seems really wrong to have this hash versus. I mean, look,
it reminds me of how you can have function and wrap the variables in typed. There, you wrap the type closely with the variable that you're using it with.
Well, the other possibility would be something like this, where you always
that solves
have
one of the magic problems, but not the other two.
Well, I mean, this could be. Wait a second, where's the ampersand here?
Presumably inside the supplied.
Yes, and after the F. Yep. Right. So we could imagine this as a one argument form. Right. I was going to point out that the what you input you have 2 lines above doesn't make any sense. I mean, that's not something that you could ever.
No, it could never work.
Yeah.
Right. Yeah, but I guess maybe supplied could just, instead of map having to look at its pure function, supplied could just look in its one argument form, and it could do crazy stuff to manipulate slots and so on.
Well, it could turn this into supplied. Could turn this.
Yeah,
into
that's what I mean. It would evaluate to the version to the spread out version.
Evaluate to it, or I see what you're saying. This could actually transform the This could meta program essentially the function in here and actually turn this into.
And at least that way it localizes all the crazy slot manipulation to be inside supplied instead of something like map having to,
right. Map and its 17 variants.
Exactly, yes.
This doesn't seem crazy to me. This is a perfectly readable thing.
Yep, I agree. I have no objection to this one argument form.
Yeah, I like it.
And that way, so in this particular case, there would never be magic with hash1. Right? No hash1 magic.
Right. You don't get a default if you're using this. If you're using the one argument form of supplied, you have to specify the name of every argument that you want.
Yeah. I think we should see whether we can move forward with this. I think these two ideas, position pattern and this supplied, both seem pretty reasonable to me. There's no absurd magic here. The only absurd magic is that you have to look up for every function what parameters does it supply to supplied.
Yep.
Okay, while we're on a roll, let's have a very quick look at this. Is this easy or is this horrifyingly hard?
It's a little detailed. I wouldn't describe it as easy.
Okay, I'm not going to get it in right now. But I mean, just in rough terms, this is the stuff that I've been wanting, where I want to be able to, I mean, what are the things, do we have a good list of what we want to be able to do? I mean, this is the thing I want to be able to echo as a debug thing and have it clean up after itself.
Right. And right, so you had this whole slew of things, and I wasn't convinced by all of the names and even the utility.
No,
of
I'm not
having all of
convinced by
these
them either, but I
things.
mean, look, the basic point is there are a lot of these things now where we have a progress monitor. It comes up while you're running interactively. It's very useful to be able to see, but it doesn't stay when it's finished. It goes away when it's finished. I find that flow very nice. Am I making sense?
Well, you know, you've said something so innocuous. You couldn't offend an MP with it, right?
Okay, okay. I mean, it's not obvious that, okay, but I'm saying that's nice. So the point with echo is we don't have a way to do that. We don't have a way. I mean, it makes me think that the right thing to do is to have an overall wrapper. Okay, so let's say it's called echo collector or echo panel, let's say.
You called it, I think, pan at echo last time.
Panel echo? No, but that's, I think, it's slightly different.
I will say we did discuss having like a super like echo handler function and decided that we liked the composability of these several like
but so what I'm suggesting here is echo collector is something you put outside of everything, and it just packages up all of the echo stuff and puts it in some kind of temporary panel.
That's exactly what I think panel echo does.
Except that maybe the well, okay, yeah, I guess I was just thinking that panel echo, I guess, sounds a little bit like good.
Yeah, I mean, I wasn't thrilled with the name. I'm just saying.
Right, but the point of echo collector will be this. Normally, if you just run expa, you'd see a bunch of echoes on the screen. Okay. Echo collector would essentially, just like sort of an old-fashioned Unix pipe redirector, would take all those echoes and put them in a panel so that they clean up after themselves. So in other words, you know, let's say you're doing this. Let's say that you've made something and you've got a few echoes, and you start putting more echoes in, and you kind of don't want to see, and you want to control those echoes better. But you don't want to have to think for every single echo, how do I want to control this? The idea here will be you just put an outer echo collector or echo handler, and it decides what to do. Because I think we were running into trouble with, you know, by the time we've got max echo limits and it's limit echo and so on and so on and so on, it just seems like the typical thing is you've put echoes in. Somehow you're getting too many echoes. But sometimes, okay, look, here's another case. You've got a piece of code, you don't know if it's ever going to be hit. Okay. But it turns out it's hit 10,000 times. You really don't want to see that. You just want to see the first, I mean, our message limiting mechanism is fairly good in that regard. It stood the test of time quite well. Right? Because what you don't want to see is just blub, 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 tens of thousands of error messages. You want to see the diversity of messages, so to speak. You want to see, oh, it's a new and different message that started coming out. And arguably, so is it with echoes. But again, it's not clear whether you want to locally limit echoes, or whether you want to globally limit echoes. Sounds to me like there's a separate discussion.
Okay.
I'll just say really quickly that in terms of, thinking about the name, instead of thinking about the GUI that it's inside of, this feels a bit to me like, a news feed or a stock ticker or something like that. And there might be something in that concept that we can draw a name from.
Yes.
Yeah. You'll notice that one of my points is that, you suggested the name panel echo last time, which was, we aren't selecting a jury here. So this is just the wrong name.
I think Steve had suggested ticker tape echo before. I might be misremembering.
Yeah, I think we've I mean, we certainly had the
right, and sort of one of the questions that's worth thinking about is, does this thing just collect the content or also the dingbats? Because in some cases, for some types of echoes, the dingbats carry useful information.
Sure, the timing, okay, timing and things like this. I'm sure it has to collect the dingbats as well. A question here is, what is the connection between this and the error handling world? Is there one? And are there echoes that should contain drillable stuff like a stack trace, for example? Like, I consider our stack trace on messages really quite successful. I don't know how other people feel about that.
Well, I find it useful whenever I turn off the what's it called? The filtering that's done by default, because usually I end up with
I just realized I have a different meeting that I was supposed to go to here. I probably should disappear to that.
Okay, well, we can take this up next time.
All right. Thanks a lot, guys. See you later.